For today's notes, we're going to be continuing section 2.6. So this is 2.6 part 2. And I want to begin this discussion. Well, first of all, the goals today are to be able to determine the equation for a horizontal asymptote, and also we'll be talking about points of discontinuity in a graph. Now, before we get into those goals, I really want to discuss asymptotes in just a little bit more detail and kind of give you a formal definition for them, but also some intuition behind it. So in general, I want you to think about asymptotes as basically when one variable, so either x or y, gets very, very close. Now that's not a super formal definition, but it does help with some intuition. So it gets very close to a single number as the other variable goes to extreme values. By extreme values, I'm talking about either positive infinity or negative infinity. So we'll see examples of this in just a moment, but I want to point out, in this case, we might be saying something like x is getting really close to, let's say, 2. And if x is getting really close to 2, then y might be going to infinity. So let's take a look at an example here. Let's do, let's go back to this example. So in the previous video, we talked about the function f of x equals 4x plus 1 over 2x minus 3. Now, we didn't actually determine the equation for the horizontal asymptote. I didn't tell you how to do that yet. We will see that later on in this video. But let's go ahead and write that down anyways. I'm just going to tell you what it is so that I can explain that definition above with an example. So the horizontal asymptote in this case is going to be y equals 2. And we also calculated the equation for the vertical asymptote. If you've forgotten, take a look at the previous notes. And this was x equals 3 over 2, or we'll just go with 1.5 for now. So here's what we're talking about with this definition. As x goes to, let's say, infinity, we're going to take a look at what y does. So when we graphed this function on Desmos, it looked something kind of like this. I'm putting the asymptotes in for our benefit. And so let's just say this is notation we've had in polynomials, but let's say we're going to the right, really far to the right, as x is going to infinity. Notice that these two lines, the asymptote and the graph, get very, very close together. And so what we would say in this case is that y actually gets really, really close to 2. If you looked at the graph, that would be 2. So it's actually matching its asymptote. Additionally, as x goes to negative infinity, so if we look in the opposite direction, y gets very, very close to 2. The graph gets very close to its asymptote. So if we're thinking back to the definition, I've looked at two extreme values for x, extreme values of x, and notice that the y values are getting very, very close to a single number. In this case, 2. So if we look back at our definition, one variable is getting very, very close. In my example, it was y. As the other variable goes to extreme values, in this case, as x goes to extreme values. So this was all a discussion for the horizontal asymptote. Now let's take a look at the vertical asymptote. let's go back to our example here. Here is the vertical asymptote. This was at x equals 1.5. And notice the graph is getting very, very close to that point x equals 1.5. If you take a look at this graph in Desmos, you'll see that the lines basically overlap if you were to graph each of these. So this is kind of the opposite. In this case, we would say x is getting very, very close to 1.5. It's heading towards 1.5, not necessarily getting there. It's getting very, very close to 1.5. And y is going to, we'll say, positive infinity. If we are kind of going this way, y is going up to positive infinity. Or if we're coming in from the other side, y is actually going to negative infinity. So some notation you will see eventually in calculus. We think about the right-hand side and the left-hand side. You don't need this for pre-calc, but just to kind of help your understanding. If I put a little plus next to the 1.5, that means I'm coming in from the right. So as I approach 1.5 from the right, then y is going towards positive infinity. And then if I put a little negative there, that means I'm approaching from the left. But again, that's not really so important. The important thing to notice here is that y is going to extreme values, and now x is going to a single number, which in this case is 1.5. And that is the definition of an asymptote. I want to pause here for just a moment and clear up a misconception. A lot of times we think of an asymptote for a graph as a line the graph never touches. So this is one of our kind of colloquial definitions for an asymptote, and it's not correct. It's a good way to think about it because I would probably change this just a little bit. I would add usually. Usually never is kind of a oxymoron. But usually the graph will never touch it. So this is a pretty good definition, but it's not always correct. It is true that the graph never touches the vertical asymptote because this is actually a domain issue. So this is a truth here. But what is false, so this is true, this is false, the graph the same is not true for the horizontal. So just something to keep in mind, it can actually touch, you could change this, it can touch the horizontal asymptote. And a good example to look at that we can analyze right off the bat would be something like y equals x over x squared minus 4. If you graph this in Desmos, y equals x divided by x squared minus 4. Notice how the horizontal asymptote is here at y equals 0, but the graph crosses y equals 0 right at that point, right at the origin. So if we do a quick sketch of this in our notes, it looked something like this. I'll go ahead and put some asymptotes in for your benefit. The vertical ones are at -2 and 2. And then the horizontal asymptote is at y equals 0. And notice right here, the graph actually touches the asymptote. So there's an example for you right off the bat. Okay, so I've dealt quite a bit in theory here. I'm trying to clear up a couple of misconceptions about asymptotes and also give you a more formal definition in order to move forward with our next steps here.